Hello everybody. So my topic is learning to walk. It's a deep reinforcement learning problem that I've been trying to solve. It's a crowd AI challenge, and they've given instructions for how to install or set up an environment to work on the OSIM environment and that they provide. So I've used the introduction to this topic is it's basically meant for people who go under surgery and how to predict their movement outcomes. So this competition would help in this movement, and the objective is to actually model a motor controller, which would give you and control of 18 muscles in the body. Uh, the main goal is to walk as far as possible within intervals of 5 seconds without falling or with restricting your pelvis angle. The tech stack used for this project is a Linux machine, Keras Python Anaconda 2, OpenSimRL, within which I've used the gate environment uh, for the gate model that I've used. This basically depends on the deep deterministic policy gradients, where it is different from DQN. TQN works on discretized space, whereas DDPG works on continuous space, wherein we're continuously getting actions from the environment and we have to continuously react to how to take the next step. So that is what a DDPG is good at. It works on a model called as actor-critic model, where the actor is actually the policy function. So you do not define any policy function here. Like in DQN, you may decide to use the Boltzmann policy, or you may decide to use the epsilon greedy, but here you don't. Your actor is the policy, and the value function is your critic. So each time you take actions in the current space, the critic will evaluate your actions and give you a signal back saying whether what action should be taken next or no. So this is a simple view of what actor critic model is. So here is the code for the actor-critic model to make that bot work. The actor-critic model here talks about 31 observations, and the 31 observations talk about your velocities, positions of pelvis, head, foot, and all the other joints of your body. And 31 observations state, and they would give an output of 18 muscles. So from that output of 18 muscles and the current observation merged would go into the critic layer. The critic layer would then provide like a temporal difference and return back a value. So that value is then evaluated according to what action should be taken next. All this actor critic network is then fed to the DDP-AG agent, which is used from the Keras library. So let's see how this model works. Basically, I have created a Docker image which is public as of now. The Docker image name is called Shweta Osim RL Learn to Walk. Shweta is nothing but the username, and Osim RL Learn to Walk is nothing but the image name. What I'm trying to do here is I'm actually trying to run the container in Docker where I've set up a Linux environment. So after running this container, I would want to get into the container. So I do a docker ps -a, and once I do a docker ps -a, I see that, okay, I want to execute that container. So I take the container ID from here, I paste it here, and I get into the container. Once I get into the container, um, I'll have to set up the environment for what do you say the environment for the bot to walk or the model to train and save weights. So these are the instructions given on the Docker page as to what steps need to be taken to actually set up that environment. So let's see. Let's run those steps one by one. Here I'm trying to create an Anaconda environment within the Linux machine. So once I say a yes, it's going to get installed. Let's just copy the next command till then. So this is gonna take some time, but yeah, it's gonna work. hopefully. Okay, in the meanwhile, I had to say that so there is a report which is present with all these observations and how the challenge has been faced and what challenges have been faced and how the problem has been tried to be solved. So here is a report that talks about that. Here are some changes. I tried to change. So this is where you see the 31 input observations. This is how it is configured. The observations are here. It was the initial value was starting from zero point 0.0, where I tried to change from 0.2 to 0.5 to see what are the network changes. And in the meanwhile, after seeing the network changes, I also saw like the pelvis restriction. The pelvis restriction was actually 0.7, but then I wanted to try values from 0.5 to 0.8 and see what are the changes that has been measured. I couldn't see like a lot of change when it was 0.8 because 0.7 and 0.8 don't have much of a difference. But yes, this is the model that I've been using, the Gate 9DO1F18 musc.osim. So once I use the Gate environment, this is the active critic network that has been showed, and all the experimental logs have been put here. So I've tried changing the optimizers from Adam to RMS proc. The only reason of using this was because I know it differs on how the processing takes place based on the learning rate. So I tried changing the learning rate from 0.001 to 0.002, 0.2, and different learning rates. Also, I changed the randomness. So the OU randomness process was changed to the Gaussian white noise process. And I think like a major change that I made was the number of steps. So the more number of steps it takes to train, the more it explores, and then the more knowledge it gains. So that is what I try to do. I try to increase the number of steps. I use the activation function from Relu to Tanich. Let's see if it is installed. Okay, yes, it is installed. I need to activate that environment. So let's activate OpenSim and let's see. Okay, so once it's activated, let's see what's the next command. Next command says pip install the OpenSimRL environment. Yes, it's cloning the repository. Let's keep us ready. So I tried a lot of experiments and all the results are present in that report, and that report is present on my GitHub link. So this is the experimental logs that I've captured. The code is in here, the results are here. You can see how the muscles have been trying to move. These are some of the results that I've pasted. Okay, so this is done. Let's paste another. Okay, yes. So yes here. This is done. Let's install Keras. We would need Keras for Keras RL. Keras RL is basically a reinforcement package which has been used to apply all these uh, all the, like reinforcement learning, deep neural net. Basically used to configure the reinforcement learning deep neural networks. So till the sixth time, let's see what else is there in the report. So my following observations are there in the report. I tried to compare like 3 types of DDPG models, and this is the score that I was getting. So my design alternative would be by using the CDQN, that is a continuous DQN model. These are the references that I've used. So the first one talks about the brief of a DDPG model. The second one talks about the Keras RL classes and their libraries that have been used. The third one talks about the OSIMRL that is the OSIM environment with reinforcement learning. Fourth one is a David Silver paper talking about DDPG agent. And the fifth one talks about CDQN. So let's see if it is done. Okay, it's gonna take a while to do this, but let's keep the next command ready. So the next thing that I have in the Git repository, so since I've tried uh, many algorithms and different combinations, if you see this folder called as saved models, the saved models is the place where all my saved experiments are kept, and it's basically saved the weights. Another folder that is present is demo and GIFs. So demo and GIFs is one important folder which has all the screenshots of different experiments present and you can see how it is walking. It has come out of its grid and it's walking. So yes, some of those experiments have been captured. So this was on 22,500 steps. Let's see when you, yeah. So you can see the movement changes. It's trying to explore as much as possible. Okay, this is gonna take a while. Yeah, so it's done. Let's see what next. So I've stored the models in this image, and if you see the data folder and go to the OSIMRL folder, from there you can navigate to the scripts folder, and now I can see how I can train my. So basically, I'm trying to train a model here with the DBPG model 2 train, and uh, so there's a visualize command, but in Docker, unfortunately, I'm not able to get the visualization, but I can still train the model. So let me just save the model as Docker um, DDPG model. Let's try and run this. Okay, it runs. Yes, so it's using TensorFlow as the backend, and let's see why is it giving me an error. So okay, let's see why is it giving me an error here. So train model, it's taking the py file. Did I miss any installation step? Don't remember. Okay, so this is let me see. So I don't think I've missed any installation step, but once you basically come up to this script and you try using this model, what exactly happens is, let's see if we've missed something. Conda install Keras, and after Keras. Oh, I think we've missed a step and we've not downloaded. Yeah, we've not done this. Sorry about that. So we've not made the Keras RL, and that's why it's giving an error for that. Let's do that. Okay, let's try and run the script again. There you go, it's running. This is the model that I've used. So it's trying to train. It will train for 3000 steps here. And the model that has been here, it's trying to act funny here, but so this is the actor model. This is the critic, and this is how it's going to train the steps. And this is the same way how it will go on your local machine. But on the local machine, you can still pull up the visualization. So I had captured a frame of the visualization, which is here. It's about some 50 frames captured. That's it. That's about how the video would look like. Thank you so much.